Okay, so we're going to be taking a look at the final exam from fall 2018, and this is question 6, which is a work-related problem. Okay, so this one again is the shape of a right circular cone, and it's resting on its base with its vertex pointing upward. So I like to draw a picture, so it looks like this. Okay, and then they say that the height of the cone is 18 feet now, and the radius at the base is equal to 7 feet. The tank contains the liquid with a weight density, so they're giving us the weight density in 51 pounds per cubic foot. So this is in pounds, a pound unit, so I don't have to multiply by gravity on this one because pounds already includes our gravity calculation. The tank is filled to a depth of 11 feet. Set up but don't evaluate an integral for the work required to pump a liquid just to the top of the tank, so to here. Okay, so now again, we need to be able to think about what's happening. So first off, it's a right circular cone, so the area of our base, again, is equal to pi r squared. The problem with this is that our radius, is going to be changing, right? So at the base, it's at its biggest, right? So the radius is 7 feet. But when I go up to here, the radius is going to be smaller, and smaller and smaller and smaller. So I need to be able to have a way of relating the radius actually to the height itself. So when I think about similar triangles, okay, I'm going to set up my ratio like this. So I've got similar triangles. So here's my height, here's my radius, right? And this is the side of my cone. So this is the height, this is the radius right here. So at its base, this is 17, and at its fullest, this is 18, okay? But now what can happen is, as we go along, right, I'm moving, because we're going up this way. As we go along, our radius, right, is whatever our radius is, but because our liquid is down here and we're lifting it up, like we're going in the opposite direction from what we were going before, right, the height that I need to be able to think about, because I've got a triangle here and I've got a triangle here. So this height, so let me write this out here. This whole thing has a height equal to 18. And then this has a height, because this is the little mini radius, little mini height that we need to look at. It's going to be 18 minus our height, okay? Because it's 18 fullest, and then whatever the difference is, wherever we're at, right, however far up we've gone, this is, that's the height that we're looking at right there. So when I set up the proportion to calculate out my radius as a function of height, I'm going to think about my radius is equal to 7. This is what it is, the radius over its actual value. As a variable, right, the radius is variable. It's variable here. And then what is it actually, right? So these are the actual numbers. These are the variable numbers right here, okay? So I'm going to cross multiply and solve for the radius here. So then the radius is going to equal 7, 18 minus height, all over 18, okay? Which we can write as 7, 18 minus height. Right, and I think they used y. It doesn't really matter what variable you use. Just I think on the mock final, these were multiple choice questions, so you'll still need to do all the work out, and then we'll talk about how you can tell if you've done the right thing when we go through the mock final. All right, so here's our radius. Okay, this is the value. This is the equation right here that we're going to plug into our pi r squared formula. Okay, so when we go to calculate out, this says what's the work. So we go to calculate out the work, right? So the integral, right, is our volume of water. Like this is, the volume starts at 0 and it goes up to 11 feet, right? This is always our bounds of integration here. Okay, and then I've got my weight density, that's 51. I've got pi r squared times the distance, right, times, and we'll call it d, I guess we're going in h units, dh. So dh is the thickness, that tiny little sliver of thickness of that, circle as we go up. So let's fill in the blanks here. So I'm going to go from 0 to 11, 51, right, that's my weight density, pi r squared. R, we said before, was 7, 18, oops, keep this here, 7, 18, this is 18 minus h squared, okay, and then the distance that we need to travel, okay, like we said before in the previous, this total thing is 18, but the liquid here only has to go this distance, but the liquid at the bottom has to go the full distance. So the distance that the liquid's going to travel is going to depend, right, on where that little tiny sliver is, right? So I've got my full length minus wherever I happen to be, okay? So if I'm integrating this little sliver right here, that little sliver is at a height h. So the distance it needs to travel is 18 minus h, because it's already gone up a particular height. and this is dh. Now, in the solution set, they basically kind of consolidated these things here. So it looks like we're going to go we're going to go from 0 to 11. We've got 51 pi. Okay, this is 7/18 squared. Okay, this is 18 minus h squared times 18 minus h. Remember, this came from our radius. This came from our distance. Okay, these are the same thing, so we can bring these together into one statement. So this looks like 0 to 11, 51 pi, 7/18 squared, 18 minus h cubed, right, times dh, and then that's it. We don't actually have to evaluate it. We can leave it as is. Okay, the hardest part in these geometric ones is the calculating out of the relationship of the radius. Okay, how does the radius relate to the height? And then that's what we're looking at here.